least. Put that at five. Civil engineering, yeah. I mean, I'm not gonna say it's easy, of course not. All engineering disciplines are hard, other than industrial engineering and systems engineers. You know who you are. You're not really engineers. You're glorified mechanics. Sorry, but civil engineering, they have a very specific range of things they touch on. It's just not as complicated. It's got a smaller range of things that you're studying.
Right, so I was watching this video again. I don't know how many times I've seen this before, but I've seen this a couple of years before, and it stuck with me because when I first saw it, to be honest, I was defensive because I started this, my degree is in civil engineering, and I started practicing civil structural engineers for more than a decade. Yeah, and as I was gathering my thoughts, I was reflecting from my own experience. I remember this. And, well, to be fair, they're talking about the degree, and to some extent, it's correct, I would say. It's accurate in terms of engineering degrees. But the thing about engineering is that when you jump onto the actual practice, much of the stuff you learn from uni, they are not, I would say, directly useful, fortunately or unfortunately. But that's the idea. I think it's true for any other types of degrees out there. You learn some stuff in uni or in college or in school, and then once you get into practice, you're going to use only a fraction of that. But that's not the point. I think the whole point of going through the degree is developing other skills, not just learning the material. But that's not the main point I want to share today. I want to share a story, a personal story, which I call the invisible expertise and the invisible complexities. Again, going back to the video, it's interesting because looking or learning, hearing from other people's perspective, especially people from a different stage of their journey. And I'm sure if I am younger, I would have a totally different opinion, like not like what I have today. So what I'm saying is the story when I cross from traditional structural engineering to software development. At first I thought I was learning programming. And then little by little as I went on, that was wrong. I'm learning a totally different new profession. And so there's this common assumption. Now I call it assumption. Before I hold this to be true, but now I call it assumption. Common assumption which perhaps shared by other engineers. It's easier for an engineer to learn programming than it is for a programmer to learn engineering. Well, again, I said it's an assumption before I took it to be true. But right now I call it as an assumption. But there's some truth to it. If we speak of just programming and making things work for the first time, especially. But then as I was saying, I was wrong because when I went to software, it's a totally different profession altogether. It's not just about making the code work and be done with it. It's not like that. So I was talking of this. I was crossing over engineering, traditional engineering to software. And the next thing is this part. I call it the pain. The pain. If we think about working with code, the common cycle, the common story is usually we have a spaghetti code after some time, after working with a piece of code, piece of software or application, you have the spaghetti code. And then you have to do some debugging and then maintenance after that. But the real thing that happens through this journey is actually an emotional cycle of confidence, confusion, and frustration. And that's the important lesson I first had to learn, had to pick up. In the beginning, I just want to write things. I just want to implement things inside the software. Pick up a piece of calculation, pick up a piece of small requirement or whatever, and then write the code, be done with it. And it's fine. For some time, it's fine. And I guess up to today, it's still prevalent idea that it's okay, it's working. The idea of it's fine, it's working. When if I draw some parallel, some analogy to that, it's like the idea between the building is standing, so obviously it's fine, right? Versus the actual engineering that went in there. It's about answering the question of how will it fail rather than just, well, it's working, it's done. It's important also to understand how it will fail, what circumstances, what conditions will it fail. It's not enough to see that it is standing. It's more of actually drawing the boundaries around the risks, around the failure modes, around the particular condition that would bring the building down. I think that's the line of thinking that we miss, or should I say I missed when I was starting with software. Because like I said, it's working. It's like the building is standing. And as I went on, I had to experience this cycle of confidence, confusion, and frustration. So if you're working with software, at whatever stage you're in, I'm sure you've somehow experienced that, or at least saw a piece of application, a piece of code that's working until it's not. And that's the same analogy. Establishing the boundary or finding that particular circumstance or condition when or where it will break. So that's an important aspect of practicing software engineering. I believe personally that's how I learn it. For example, if I have a piece of app, let's say, and then there's this function that's broken for whatever reason, maybe somebody else changed, or even you, or say, my example, I updated a piece of code somewhere, and then suddenly function A breaks. And then I have to look, it's broken, why? Because I changed this. Well, it's fine. All I have to do is to update this accordingly, right? And the next thing you know, there's another function B that is broken because of that update. And if I push this further, that function B would break function C to Z if I change it ever so slightly. So that's the idea of spaghetti code, right? In the beginning, we wouldn't bother, we wouldn't care, but until you experience that, until you experience the pain of fixing that, having to fix that, you'll never get to appreciate these ideas. What I'm saying is, if we go down deeper to the discipline of software engineering, we would start talking about the proper systems design, architecture, boundaries, interfaces, those kinds of things. And I was guilty of this in the beginning because, to be fair, I also extended some effort to learn them, at least in theory. During my early days especially, I was reading some, books and stuff and articles and try to understand what are these things, what are these algorithms for, what's this O notation for, what are these data structures are, linked lists and stuff. And it feels good when you understand them, even in, intellectual level. And as I was saying earlier, the understanding is separate from appreciation. And it took me nearly 2 decades of experience with those two different disciplines, structural and software, for me to appreciate that each one has its own sets of complexities. Each one has its own set of expertise that one has to develop through experience. And there's no way for you to compress that process. There are no shortcuts. There are no hacks. You just really have to spend that time, that those days in the trenches, as they say. So you have to experience enough of the pain for you to appreciate why this rule exists, why someone says this, and why someone decided to come up with some pattern, some solution. And that's your answer because someone was there before who experienced the pain, the trouble of having to go through all these cycles. And then, you don't get to appreciate that when you are starting out, right? The priorities are different. Once I begin to understand that, I get the sense that, wait up, why does it feel like I've been here before? I've experienced this before. And that's where I drew lots of inspirations and connecting ideas, parallel ideas, maybe related directly or indirectly ideas from structural engineering, because at the end of the day, it's still engineering. That's where you get to appreciate the idea and to me personally, the problem solving aspect of engineering. And it also connects to something deeper, deeper in me personally, because since I was like 11 or around that age, I already knew that I wanted to be an engineer, but I just don't know exactly which particular major, which particular discipline. And that's because something in me loves the idea of solving problems, of understanding certain systems in order to come up with solutions. That particular theme is present all throughout my career, regardless whether I'm working on a structural project or a software project. And that speaks to me in a in a deeper way, in a deeper level. But that's how it happened to me personally. I just want to share it with you. And so, the conclusion was, essentially we have the same problem. As an example, in a typical structural project, when you submit your design, then contractor will start to implement it on site. And one day you receive a call around RFI, request for information. Hey, engineer, we got this problem. We cannot source this set of bolts that you specified in the drawings, or even the bars on the concrete. And common questions would pop up like, can we instead use blah, blah, blah instead of this? Those common questions. What if we change this? What if we move this? What if, say, in a slab, for example, you specified 10 mils at 200. What if they will say, we cannot fit in the 200 spacing. We need to go 300. Is it okay if we use 300 spacings, but we increase the diameter, for example, let's say 12 or 16? So sometimes it's easy, sometimes it's hard. Then if I draw some parallels on the idea, I can look at it as the spaghetti code example. Depending on how your structure is and how you define your design workflow, it could be a spaghetti or it could be something architecturally clean, something that has clear separation, clear boundaries. But sometimes it's not possible, especially in structural engineering. But it's the same idea. You have to go back to the drawing board. You have to go back to your calculations, to your drawings, and try to resolve that question, whether would it work with your particular set of designs, with the other constraints that are already set, with the other parts of the design already set, already drawn, already finalized for whatever reason. Because, like I said, it's already submitted, right, for construction. So it's the same thing. If if that's an easy fix, if it's like function A, however, it's going to be a nightmare, right? In that particular example, the bar spacing, it could be easier, right? But what if they say, oh, we cannot use a 200 mil slab in here. Can we reduce it to 150? Now that's a different story, right? Because it might affect, depending on your building configuration, it could have an effect on how you design the floors or the floor system to be, say, your diaphragms, how you transfer your lateral, horizontal lateral loads to your main vertical elements, right? Say you have to have 200 mils of slab in order for you to have that effective diaphragm action to transfer them to, your columns or your walls or your braces. What if that's a problem? Now that's a classic case of spaghetti, because you have to understand the change, that what the change is, or what that particular change, the thickness of the slab, how would it affect the transfer of your diaphragm forces towards your vertical system? That's more like a spaghetti, because you need to check the load path for that, and then account for whatever distribution it would give you, and then your vertical systems would have to be checked again if they're still okay with that. So that's a classic case of a spaghetti situation in a structural engineering project, that perhaps you could, I'm not sure, but maybe you could have a different way of approaching it, so that when these systems change, other parts won't be affected as much, like literal decoupling in code, right? But I'm not sure if the same thing could be achieved as effectively in a physical system. But that's a different story. But what I'm telling here is the same sets of complexities, the same sets of systems thinking, the same sets of problems, system problems, they are still present, whether you're dealing with a piece of software or a piece of physical structure. That brings me to that idea. Experience changes what you see. Understanding is not the same with appreciation. I like to use a somewhat poetic line here. They say, a picture paints 1,000 words. If I put a picture in front of you, much of the interpretation there would be based on the background of the person who's looking. You know these psychological tests where they show you a pattern, like ink blots of sorts, and then they will ask you, what do you see? Do you see an elephant, or do you see a bottle or something? And that will somehow tell you, or tell you something about you based on what you see. So it's the same idea here. If you give a piece of artifact to two engineers, let's say a junior and a senior. Now you're seeing the point, right? They would have different perspectives based on what they see. So let me think of an example. Right. So if a junior is looking at a particular piece of design, for example, okay, it complies with this provision of this particular standard, this particular code. But for a senior, it might tell a different story. It would be like, this because it avoids this problem which we had encountered before. Or a much more specific example would be, we've dealt with this contractor before. We know this contractor. They don't like this. They don't like that. It's a pain to deal with these guys. Those kinds of things, they only come with experience. And unfortunately, maybe, they come from a painful experience sometimes. And that's just how we learn sometimes, unfortunately. And so it's like also in designing a software, if you look if a junior looks at a particular snippet of code, okay, it returns these values. This is the input that it needs. But if someone else looks at that, I've seen this pattern before. Why? Because this particular pattern fits well with the underlying framework, for example. Or this framework does not allow another way to do it. It's part of its, opinion. So again, you can give the same artifact to two people, and then they would definitely have different interpretations or perspectives, just like the video earlier, right? That's why it's interesting to see other people's opinions too, right? When they are at a different stage of the journey. And so I think this is very timely. The timing is kind of perfect, or could never be more perfect, because of AI. I'm speaking now more on the software side, more on the practice of software engineering. Because, well, the code generation is easy now. The AI could give you outputs, even before your coffee gets cold. You know what I'm saying? And it's good at that. It's good at that. But the unfortunate thing is, some people still think that software engineering is just producing the code, right? So it's just like, well, you see a structural engineer, they're just drawing plans, right? I remember I remember one time there's a common anecdote around construction sites that the master builder or the foreman, they always say that, the engineer just draws the plan, we make things happen on site. They don't know anything. They just draw things. I don't know what you make out of that story, but it's essentially the same thing. When we comment on something about software engineering, it's just, you're just typing code. It's just syntax, right? So you see, it's not that, because before, people think you're typing, and then now AI is doing the typing. Different modes, but the misconception is not corrected or addressed, because in the end, it's about making it work versus knowing its boundaries, knowing its limitations, or better yet, designing its boundaries, designing its limitations. But that would only come if you understand enough of the system for you to be able to put some controls around it. And I think that's the essence of us engineers, regardless of our discipline, of our major, whether you're civil, mechanical, industrial, system, software. In the end, we're trying to understand enough of the governing constraints, the systems around us. In the case of structural, of course, the physical systems, the laws of physics. And then designing a piece of artifact, a piece of structure that would agree around those. That would be, that would be contained inside those constraints, and that we understand enough of it to know its limitations, so that we can address, the risk and the problems before they arise, the dangers, the impacts that they would cause. I think that's the essence. That's in the bottom of it. So the message I'm trying to drive here is, when we look at a piece of work, whether it's a drawing, a plan, a report, or a piece of app, a software, we just see the surface, right? But we almost always take for granted the invisible things that allow it to be, You know, those things. And I said earlier, it's the invisible expertise, the judgment, the labor, the sweat, the all the pain and learning experiences that you pick up once you make the mistakes. Those are only available through experience. There's no shortcut around it. So in terms of software, even today, they say don't study computer science, don't study software engineering anymore because of AI. There are different things. It's not just about producing the code. And maybe this time is a somewhat contrary to that advice. Maybe it's a time that you should perhaps invest more on understanding those things, right? Yeah, so let me know your thoughts, your ideas, especially your experience. That's the main interesting thing about it, right? How you experience these things and how you process that experience, right? Because for some people, they spend years and years doing something, but it just doesn't stick because of how they don't want to engage the experience, how they don't want to process the painful experience, you know. But the bottom line is just take the painful parts and learn from it. That's the reason why we have these best practices, lessons learned. That's why they call it lessons learned. So thank you for watching. Let me know in the comments if you have questions and let me know your experience. I would love to hear them. Thank you.